Jane, can you please get me some baking powder from the drawer?
Okay, Uncle. Here it is. Look, Uncle, something is going on.
Where?
Right here where I spilled the vinegar.
Aha! I think the vinegar is reacting with the baking powder.
Oh, I get it now. Vinegar is an acid, so it reacts with baking powder. It means that baking powder must be a base.
You're certainly right, Jane. Have you ever wondered how many substances around you are acids or alkalis?
No, Uncle. Can you help me do that?
Okay, Jane. Can we collect as many items as possible so that we can determine whether they are acids or bases?
Okay, Uncle. I have some in the kitchen. Vinegar, lemon juice, sugar water, table salt, toothpaste, handy, distilled water, soap solution, and tap water. How are we going to determine whether they're acid or alkalis?
Oh, we are going to use litmus paper.
I read that there are many indicators that can be used.
You are right. There are many indicators, but we are going to use a universal indicator. This can be in the form of a liquid or a paper.
Is there a difference between the two?
Their basic function is the same. However, the litmus paper has two colors only, red and blue. It just shows you whether a liquid is an acid or an alkali. The universal indicator, on the other hand, has many colors. It doesn't only show you whether a liquid is an acid or an alkali, but also shows you how strong or weak it is.
I see. Now I get the picture. Let's begin. Where are we going to get the indicators?
I've got some in my pocket.
What did you need them for?
I tested the pH of the soil the other day.
What is pH?
pH is a scale used to show how alkaline or acidic a substance is. It is a series of numbers from 0 to 14. Each color corresponds with a given pH value on the universal indicator. You will see what I mean when we do some tests.
Okay, we can start with the litmus paper. Let me get my notebook so we can record the substance and test results.
Okay. Okay, that's being scientific. It's a good thing to record your observations for later reference.
So, for tap water, the litmus paper stays the same. The soap solution stays the same. In vinegar, stays red. In lemon juice, stays red. Sugar water stays the same. The salt solution stays red. In the handy, it turns blue. Toothpaste, it stays red. And for distilled water, the litmus paper stays red.
Great. Now that you have used the litmus paper, let's start with the universal indicator.
Okay. What do I do?
Well, you just dip it in the solution the way you did with the litmus test. Then compare the resulting color with the standard colors given. The color corresponds with the pH of the substances.
For tap water, the pH is 5. For soap solution, the pH is 6. For vinegar, the pH is 2. For lemon juice, the pH is 1. For sugar water, the pH is 5. For the salt solution, the pH is 5. The handy 11. Toothpaste 6. For distilled water, the pH is 7.
Alright,
How can we tell whether an acid is a strong or a weak acid?
it's because the smaller the pH value, the stronger the acid. The weaker acids are closer to, but below pH 7.
What about pH 7?
It's neutral. For example, the pH value of distilled water is 7. Therefore, it is neutral.
What about alkalis? How do you explain them?
Well, for alkalis, the bigger the pH value, the stronger the alkali. This means weaker alkalis are above but closer to pH 7.
So far we have dealt with weak acids and alkalis. Where do we find strong acids and bases?
That's a very good question. You have noticed that in homes we use weak acids and alkalis. This is because they are safe to use. Strong acids and alkalis are dangerous to use. Therefore, they are kept in safe places like laboratories. Let's go to the laboratory and I will show you.
Okay, but we have to clean up first.
Now we are going to deal with weak and strong acids. Here we have sodium hydroxide. Here we have dilute hydrochloric acid. Here we have dilute sulfuric acid.
You said earlier on that they are dangerous to use. How safe are they to use?
In general, you should treat these chemicals as potentially dangerous. These are relatively safe to use as they are not concentrated.
Okay, I will start with the litmus paper, as I did in the other tests, and proceed with the universal indicator.
That's good, Jay. Go ahead.
Let me dip this red litmus paper in the first solution. What is wrong? There is no color change.
I see nothing wrong with your test. It's...
Oh, I have figured it out. If the red litmus paper does not change color, it means the solution is acidic. I can take the blue litmus paper and there it goes red. It is hydrochloric acid. That's why acids turn red in litmus paper.
That's right. Continue testing the rest.
I will dip this red litmus paper in the sodium hydroxide solution. It's turning blue. I will dip the red litmus paper in the dilute sulfuric acid. The red litmus paper stays red in the dilute sulfuric acid solution.
Okay, test them with the universal indicator paper.
Sodium hydroxide and sulfuric acid. Let's see the results we get with universal indicator paper. For sodium hydroxide, the pH is 11. For sulfuric acid, the pH is 1. And for hydrochloric acid, the pH is 1.
Your results look great.
What makes the acid strong or weak?
That is a very interesting question. You see, in solution, an acid will have hydrogen ions as the only positively charged particles. This is so because the acid ionizes in solution, meaning that it forms ions. For example, hydrochloric acid, HCl, becomes H plus and Cl minus. We say that HCl is a strong acid because it almost completely ionizes into solution.
Weak acids like vinegar don't almost completely ionize in solution. Then what happens?
In this case, as the acid ionizes, some ions will combine to form the acid.
Can't I make an acid weaker by diluting it a lot?
As I have already explained, dilution doesn't affect the strength of the acid. It affects the concentration of ions in the solution.
What about alkalis? Does it mean that strong alkalis are almost completely ionized in solution and weak ones are not?
Exactly the similar rules apply here also. Dilution doesn't affect the strength of the alkali.
Now I understand the concepts of strong, weak acids and alkalis.
Thank you, Jane.
Now for the SMS competition question. To SMS, you must enter the keyword for the competition and then send the option A, B, or C to the number 8555. The keyword for this program is assets, and it is spelled ACIDS. One SMS costs $3. Don't worry, it is as easy as 1, 2, 3. What is the pH for distilled water? Is it A, 12, B, 7, or C, 5? SMS your answer to 8555. The number again is 8555. All correct answers will be entered into a lucky draw. The winner will be announced within 3 days, and if you are the lucky winner, I will contact you to collect the prize at the nearest NAMCOL center.
Quiero ver